This is another of our project, which name is an E. coli screening machine in water by fluorescence technique. The cause of the water pollution first is flood and drought. Second is climate change. Third is urban coal. Fourth is sewage. Fifth is industrial coal. And sixth is the artificial coal. And the problem affects the 1.1 billion lack to access the clean water and 4 billion case of diarrhea per year, 1.8 million case in death, and the last is problem affect to child who are less than 5 years old. This is the symptom that you will be if you drink that contaminated water, like body, diarrhea, vomiting, fever, pneumonia, and urinary tract infection. Who are at risk from E. coli? The answer is everyone. And the traditional E. coli detection method, first is standard case counting, and the second is most probable number, which this is mean that if you have negative testing, it have the E. coli in the water.
And here is our approach. Our approach is to use fluorescence spectrometry to observe the amount of number of E. coli inside the sample. Our system built up from using 2F system, which the first one for excitation and the second one for emission. For excitation, we use the LED to shine the light at 360 nanometer and passing through the excitation filter, which is 360 with the plus minus 10 nanometer band. So the light will focus it on the sample. The reason that we are going to focus it on the sample for both system is that to observe the maximum intensity and using all the photon to signaling our photodiode. And in the emission side, we use emission peak started from 400 nanometer, and we are going to observe the peak at 445 nanometer. The reason that we use emission filter is to make sure that the excitation light source are blocked by our filter. So the signal that we observe from photodiode will become the pure signal of fluorescence molecule. Next, the fluorescence molecule that we are going to use to observe the amount of E. coli is 4-MU. The 4-MU formation from the beta galactooxidase, which secrete from E. coli, react with MAC to form the MAP, which is 4-MU in our cases. 4-MU will respond to our fluorescence system that I mentioned in previous slide. And here is the result of the value that the sensor can read, started from the low concentration to the high concentration. It's shown that our system can observe the appropriate the curve, like the is proportional to the concentration of 4-MU inside the sample. And this is the result of the temperature system. Sorry, in our setup, it will have the temperature regulate system, which basically implement from the PID controlling to regulate the temperature. Here is the starting point until around more than 30 minutes. It's shown that when it reaches the cell culture temperature, it can maintain the temperature of our system. Yeah, is our market in Bangkok, they have more than 20,000 vending machines and more than 20% of them are contaminated, and other provinces more than 10,000 machines with more than 40% contaminated. There are no regular testing even with the mandate due to the cost and the time. So our advantage will reduce cost, portable, and time saver. It can reduce cost because this system can be repeatable, and it also portable because the setup is pretty small when compared to the traditional E. coli detection. They have to done a lot of experiment, a laboratory experiment that require a lot of material to form the experiment. But in our case, we use only one dye and our optical system. And the last thing is it is time saver because we can generally use the sample, mix it with our substrate, and then test by our optical system. The response of the fluorescence molecule, normally it use only in nanosecond scale. So our system is much more faster than traditional experiment, and also the selectivity of the fluorescence molecule is typically higher than the traditional one. So this is our presentation. Thank you for your attention.
Yeah, thank you for your talk. So it's open for questions. Are there questions from the jury?
I think for E. coli detection system, your system a little bit too big. Have you think about any other approach you can use to miniaturize your system?
Yeah, I see. It depends on the focal length of the lens that we use. But from our result, I didn't show the commercial product. It quite shown that our result is much in our system is much more sensitive than the commercial product.
I wouldn't say your machine is much smaller than the commercial product because commercial product has more function and more. Actually, they serve for different purpose. Because
for the E. coli only for specific wavelength only, they have some commercial product too.
Okay, so because when I saw your optical system, actually you can combine these two optical systems together. So that's why I think you should try to miniaturize your system.
Thank you for your advice.